Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right, it's from 2015. The question read, the complex numbers Z1, Z2, Z3 are such that 2 over Z1 equals 1 over Z2 plus 1 over Z3. Z2 is equal to 2 plus 3i. Z3 is equal to 3 minus 2i. I squared is of course equal to minus 1. Write Z1 in the form a plus bi, where a, b is an element of Z. Okay, so we've 2 over Z1 and we have to find Z1. So that's equal to 1 over, now instead of Z2, I'm going to put in 2 plus 3i plus 1 over, and instead of Z3, I'm going to put in 3 minus 2i. Okay, and I have to solve this for Z1. Okay, so there's a couple of ways of doing it. One is fractions, one is obviously fractions. This is 2 fractions and a plus. So I would need a common denominator. So my common denominator is the denominators multiplied by each other. Okay, and then depending on how you do fractions, you can multiply each term by the common denominator, and I'm just writing that here in black for you, by 1 over 2 plus 3i. So I'm multiplying the common denominator by this term, plus the common denominator 2 plus 3i, 3 minus 2i, by this term here, by 1 over 3 minus 2i. Let me extend my line. And what you'll see is that this will cancel with the same one on the common denominator, and he will cancel with the same one. So that in effect you're left with, on the bottom, 2 plus 3i by 3 minus 2i, and on the top you have 3 minus 2i by 1, plus 1 times 2 plus 3i, okay, or the other way around, it doesn't matter. Okay, or if you do another way of doing fractions, 2 plus 3i into the common denominator, cover the one that it is, so it's 1 times the other one. Okay, it's a bit like a crisscross. 3 minus 2y into your common denominator, cover it, and it's 1 times the other one. Okay, so whichever way you do fractions, do here the same way. And then let's start multiplying. So I have 3 minus 2i on the top there, plus 2 plus 3i there, and on the bottom, so it's 2 by these two terms, plus 3i by these two terms. So 2 3s are 6, 2 by minus 2i is minus 4i, plus 3i by 3, 3 3s are 9i, and then I have plus by minus is a minus, 3 2s are 6i squared. Okay, so I hope that makes sense. Then to simplify, it's reals with reals, so 3 plus 2 is 5, minus 2i plus 3i is plus 1i, or just plus I, and then on the bottom, so my I squared will be minus 1, so minus by minus I'll end up with the plus 6 here, so I'll have 6 plus 6 here to give me 12. Okay, I squared, that's a real number, so that's why he gets added to the 6. 6 and 6 is 12. And then I have minus 4i plus 9, or 9 minus 4 is plus 5i. Okay, so I'm just going to go on to a new page so I'm not squishing it. I'm going to write 2 over Z1. This is where I'm at, is equal to 5 plus I over 12 plus 5i, I think. Let me just check. Okay, so basically we have simplified this to 5 plus I over 12 plus 5i. Okay, so let's see what we'll do now. Yes, well, let's resolve him. Okay, so how do you divide 5 plus I by 12 plus 5i? Well, you multiply above and below by the conjugate of the bottom. Let me just see. No, do you know what? I'm going to do something first, just to make sure that I don't end up dividing again. You see the way this is 2 over z1? Let's invert him as to z1 over 2, okay? Because I want to solve for z1, not 1 over z1. I want z1 on the top. I want z1 equals. So what I do is I've inverted him, which is perfectly acceptable as long as I invert this side. So let's invert him to 12 plus 5i over 5 plus I, okay? Why am I doing this, guys? If I'd left it the way it was, I think I would end up with another division where I'd have 1 over x plus yi, whatever answer I get for dividing them. So I just want to do one division because, as you know, division takes a while. So this is good then. I can multiply across by 2 when I have x plus yi for this one to get rid of the 2 on this side. Okay, so let's divide these two. So how do you divide complex numbers in rectangular form? Well, you multiply above and below by the conjugate of the bottom, which is 5 minus I. What I do to the bottom, I must do to the top, okay? So just as an aside, I'm going to just explain briefly why we multiply by the conjugate. And the conjugate just means change the sign of the imaginary part, not the real part. Leave that one alone. It's just the imaginary part. Okay, so let me do this. So 2 2s are 4. 2 by minus 3i minus 6i plus 3i by 2 plus 6i plus by minus is a minus 9i squared. Okay, but I want you to draw your attention to this bit in the middle. Minus 6i plus 6i will cancel. Okay, and this is always going to happen. The complex numbers in the middle, the imaginary parts, are going to cancel. When you multiply a complex number by its conjugate, you cancel the imaginary parts and you're left with just a real number. Because remember, this is minus 9 times minus 1, so it's a plus 9, and 4 and 9 is 13, okay? So when you multiply a number by its conjugate, you get rid of the imaginary part of the number, you're left with just a real number. In maths, you are not allowed to divide by imaginary numbers. So we must change the denominator to a real number. That is why we multiply the bottom by its conjugate. And then, of course, what I do to the bottom, I must do to the top to preserve the equation, okay? Because, as you know, any number over itself, 10 over 10 is 1, 3 over 3 is 1, x over x is actually 1. 5 minus I over 5 minus I is 1. So in effect, you're only multiplying that equation by 1, in theory. Okay, so you're not actually changing the equation. You're just writing it in a different way. So that's why above and below has to be multiplied by the conjugate of the bottom. And learn that off by heart. Multiply above and below by the conjugate of the bottom. So let's multiply out those. Let's see what we get. I'm going to do the top line first, 12 by those two, and then 5i by those two. So 12 5s are 60. 12 by minus I is minus 12i, plus 5i by 5 plus 25i, plus by minus is a minus 5i squared. On the bottom, 5 5s, 25, 5 by minus I minus 5i, plus I by 5, plus 5i, plus by minus is a minus I squared. Okay, and happy days, when they cancel, you know you're doing okay. So z1 over 2 is equal to, so this is going to be minus 5 times minus 1, so net effect is a plus 1. And that's what always happens. If this is a minus 5, it'll end up being a plus 5. So I can see there I'm getting 65. 60 plus 5 is 65, minus 12 plus 25, or 25 minus 12 is 13i. And on the bottom, he's minus 1, so 25 plus 1, I'm getting 26 on the bottom. Okay, so now I'm going to multiply across by 2. Because I know then the 2 and the 2 will cancel there. And I'll have Z1 being equal to 130 plus 26i over 26. So you can break that into the real part plus the imaginary part. Okay, so you just put the real part over 26, the imaginary part over 26, and that's your x plus yi. 130 over 26 is 5. So the answer I get for that one is 5 plus I. Okay, so that's one way of doing this sum. You could, of course, have done it in multiple divisions. In other words, you could have worked out 1 over 2 plus 3i. And in that one, you would have multiplied above and below by the conjugate of the bottom. Okay, and you would have got an answer for that. Okay, so that's one part. You would then work out this one. Okay, so 1 over 3 minus 2i, and you multiply above and below by the conjugate of the bottom. And you would have got that. And then you would merge the two together and so on and so forth. And eventually you'll come down to this. Okay, and then of course you have to do all of this page again. So whichever way you prefer, try it. It's a longer way of doing it, perfectly acceptable way of doing it, but with fractions is the easier way. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.